All right, let's see how it went, my friends. So let's get started on the proof. I'm hoping the basis step is going well at this point pretty consistently. So for the basis step, you are going to kind of look at what happens when n equals 1. So for n equaling 1, what would that yield? It would give you s sub 1. And then the tricky thing about this one is on the left side, they've got the 2 factored out. So you'd want to make sure that you imagine what happened if you distributed the 2 in. And so your first term would be 2 times 1 for the term by term side. And then on the right side, your first term would be calculated as 3 times 1, or sorry, 3 to the first power minus 1, and these two things are indeed equal. So congratulations, you just showed that you can get your foot on the first step of the ladder. Okay, now for the inductive step. All right, 2 pieces to that. First piece is the assumption piece, so we assume that there exists some k value that's from the natural number set such that our claim holds true for n equaling k. So what would that look like? So s sub k would be 2 times 1 plus 3 plus the quantity, plus 3 squared, 3 cubed, all the way up to, and the kth term would be 3 to the k minus 1. And our claim is that that could be calculated as 3 to the k minus 1 instead. Okay, so here's our claim. So our claim is you can get your foot on the kth rung of the ladder. Okay, now the burden of proof is to show that you could also get to the k plus 1 rung of the ladder. So now all we must show is that our claim also holds true for n equaling k plus 1. Okay, so let's get started on that. So s sub k plus 1 on the term by term side, what would that be? That would be 2 times the quantity, 1 plus 3 squared plus 3 cubed, all the way up to, you'd still have the k plus 1 term, or sorry, the k term there, but then you'd also have one more term. You'd have that, which would just end up simplifying to be 3 to the k. Okay, now off to the side, let's talk about what's our goal. Our goal is to show that we could simplify this term by term mess down to be this expression where n is just k plus 1. There we go. Okay, so that's our goal. So let's get there. Okay, to get there, the one tricky piece on this problem is that 2 right there. Remember, 2 is supposed to be distributed into everything inside the parentheses. And so to get anywhere, I'm going to take a couple steps just because I don't want to lose anybody. So what I'm going to do first is really simply copy everything exactly the way it is. And then I just wanted to clean that up. So that's just 3 to the k, right? Okay. The next step would be we need to use our claim up here. And so our claim, takes care of all the way up to here. So before I can use that though, I need to account for the fact that 2 is supposed to be multiplied by everything in the parentheses. So I'm going to break this expression up like this. 2 would be multiplied by the 1 plus 3 squared plus 3 cubed all the way up to 3 to the k minus 1. But then this last term right here would also need to be multiplied by 2. And that's a common place where kind of people don't realize that that had to be there, and then they can't get anywhere with their proof. All right, now by our assumption, we can swap out this term by term piece for this expression right here, which is 3 to the k minus 1. But then we'd have our k plus 1 term tacked on at the end. And now our goal is to show that this would simplify down to be this expression over here. So now it's just a little bit of algebra to get it there. So for starters, I'm going to group things by like terms. So you have 1 3 to the k plus 2 more 3 to the k's. I'm going to put those next to each other, and I'm going to have the minus 1 at the end. Now it's just a matter of counting things up. If you have 1 3 to the k and someone gives you 2 more 3 to the k, then you have 3 3 to the k. And if you don't see it yet, take a look at where I'm at and where I want to get to, and think of 3 as 3 to the 1. And it's just a simple property of exponents. 3 to the 1 times 3 to the k would be 3 to the k plus 1 minus 1. Boom, just got it. All right, my friends, so what have I done? I showed that you can get to the first rung of the ladder. I showed that if you can get to the kth rung, then you can also get to the k plus 1, which means I just showed you can climb the whole thing all the way up to infinity. Come on, that's adorable. All right, so my conclusion would be, therefore, S of n, which was defined as 2 times the quantity 1 plus 3 squared plus 3 cubed all the way up to 3 to the n minus 1, that is indeed something you could do 3 to the n minus 1 with instead of doing it term by term, and that would be true for all n from the set of the natural numbers. Proved. All right, my friends, I hope this is at least starting to make sense and that you do okay on your problem set. Make sure that you follow the format that I have here, where it kind of looks like a paragraph proof. I know the textbook shows things that look just like outlines, but when I assess you on this concept, I will be looking for the words and the format that we've been demonstrating in the last couple of examples. All right, take care, everybody.